So my name is Andrew Hall. I'm the program manager for the Visual Studio Debugger. I work on the broader diagnostics team in Visual Studio. We own debugging, perf tools, IntelliTrace historical debugging, and we build the Android emulator that you saw in the keynote this morning. So a broad range of things that we work on. Today we're going to talk about debugging tips and tricks for .NET developers. In Visual Studio 2015, we're going to hit on a lot of the new stuff that we've added in the debugger. But a lot of it will be applicable across languages. So everything I'm going to show today is in .NET with C#. It all works for VB as well. But much of it would actually work if you're debugging C++, even if you're debugging on iOS or Android using Xamarin or C++ Stack or something like that. So a little bit about myself. After I graduated from college, I went and wrote line of business apps for a couple years in VB.NET. I went back to graduate school, got my master's degree in computer science, and then had the opportunity to go join the debugger team at Microsoft. I'd been using the debugger as a VB.NET developer for years, loved the product, so it was an opportunity I couldn't turn down. Joined Microsoft almost 7 years ago, so I've been working in this particular team for about 7 years. So why are we all here today? Oh, sorry, submit an evaluation for each one you attend. You get entered to win a prize. So why are we here? I'm assuming every single person in this room is here because you have to debug as part of your day job. And here's two quotes you can read really quickly. But it turns out that we spend a lot of time debugging problems when we're a developer by trade, but you're not really adding value when you're debugging problems, right? You actually get paid to make things work, and you get paid to write new features and add functionality to your application. So any time that you can save finding problems is actually time that you're being a better developer. And so today, I hope to show you some tips and tricks for how to get the most out of the debugger to find problems more quickly. I don't think you're going to see anything that's going to find your bug for you. We haven't invented that button yet, and we really haven't invented the fix it for you button yet. But hopefully, you'll come away with something that will help you understand, oh, wow, I've never seen that before. Yeah, that would save me a lot of time. So it's all about time-saving tips and tricks for the ability to find problems in your code faster. So the agenda, I'm going to briefly show you 4 slides, 4 new things. These are things that I don't have time to talk about, but there's a URL at the bottom. You can go grab the slides afterwards. You can go investigate them. And all of the content's going to be covered in other talks. So you have an opportunity to either watch those or go watch them if they've already happened or you're not able to attend them. We're going to try to demo Visual Studio. We're going to actually spend time in the debugger with the product for about 50 minutes. And then at the end, I put together some slides of bonus multi-threading tips if you do multi-threaded debugging. These are slides, again, with some callouts for features you may or may not be aware of, with URLs where you can go learn more about those. I don't think we're going to have time to get to those today. If by some miracle we do, then we can take a look at those in the debugger as well. Does that sound like a good agenda to everybody? Yep. Excellent. So first thing I talked about new. We've added a diagnostic tools window into the debugger. When you press F5 with Visual Studio to start debugging, the first time, if you go pick up the RC and download it, you're going to see this pop up off to the right. It includes performance information. It includes some historical information. So we record when you break in the debugger, whether it was a step, whether it was a breakpoint. And in the enterprise SKU, we also pull in the output window content and IntelliTrace events if you're familiar with that feature. This will be covered in both the performance tools talk that I'm going to be giving tomorrow in conjunction with my colleague Angelos Petropoulos, who's the program manager for IntelliTrace, and he's giving a talk on IntelliTrace on Friday, where he'll also be covering the IntelliTrace specific functionality of this. So perf tips. Anybody seen this yet in Visual Studio 2015? Almost nobody. So we brought timing information into the debugger. So as you step and run between breakpoints, you can do order of magnitude measurements to figure out how long your code took to execute. So this is a really light way in the course of normal development and debugging to just get a ballpark idea for how long things take to execute. You don't want to use it for individual milliseconds, but if you step over a query to a database and it takes 6 seconds, it was pretty close to 6 seconds, right? So no more going and adding stopwatches or trying to time things that way in your code. Thank you. And that will be covered in the performance tools talk tomorrow evening. UI debugging tools for XAML. These are tools that let you do for WPF and the Windows Store app XAML, inspect the live visual tree, inspect properties while the application's running. If you're familiar with the browser tools, you just say click on the element, and it'll show you all the properties. So we finally brought that into Visual Studio. And then the last thing, which you saw called out in the keynote this morning, is Visual Studio has added support for Android, including C# via our partnership with Xamarin. There's actually a checkbox in the Visual Studio 2015 RC that shipped today to say, yeah, I'm interested in doing Xamarin development for iOS, Android, and Windows. You check that, click install, it'll go pull down those bits and install those for you. So that's a very quick whirlwind tour of some stuff that's available to you that we're not going to talk about today. All right, so let's go ahead and jump over and let's start looking at Visual Studio as promised. We want to spend as much time in the product as we possibly can. So I have a WPF application that I've written. Can people in the back see? Is that big enough? I see some head nods. Okay. And the idea was when it popped up, I wanted it to say, hello, build, because I know that this is going to be everybody's favorite talk at build, and I'm going to get asked to give it again. So I want to make sure that I can just via a parameter pass in the application or the name of the venue, so I don't have to go remember to change code. I just have a command line parameter. It says hello, whoever I'm talking to. But clearly, it's telling me that I didn't actually provide the argument correctly. So what I want to do is I want to configure my project properties to pass this in. Do you know that you can configure your project properties in Visual Studio to set command line parameters to your applications? So I'm going to right-click. I'm going to say properties, and it's going to take me to the project properties page. There's quite a few options in here for the debugger. I can choose various start options. So by default, it's going to launch my project. But if you have a DLL or something, you can choose to start an external program. So if you're developing an Excel plugin, when you create a project, by default, it creates a DLL, and it has start external program, and it has Excel listed here. You can obviously start the browser with a URL. As it says there, we have command line arguments. You can configure the working directory for your application. You can set up remote debugging if you want remote F5 to work. And then you have some debugging options here where you can enable native code debugging if you have some C++ libraries that you use as well. Check this checkbox, and you'll be debugging your C++ and .NET code at the same time. You can even enable SQL Server debugging if you're communicating with a server that way. And the final option is enable the Visual Studio hosting process. Anybody here know what the hosting process is? No? OK. So hosting process is an optimization that the project system does where for many .NET application types, it actually has your application already running, and it's loaded all of the framework assemblies that you've referenced. So when you press F5, we start up a lot faster. Every now and then, so this is going to be a little bit small. My apologies. But you can actually see that there's a photo project archive.wpf.vs host here. So my project is actually already running. And if you go to your build output directory, you'll see the name of your executable, in this case, project archive.wpf.exe, and a project archive.wpf.vshost.exe. And so this makes things start up faster for you when you're debugging and enables some interesting scenarios for using things like the immediate window that we'll talk about in a little bit. So, all right, so I needed to add a conference flag here. And so this is build. So now I'm expecting that when I launch this, it should say hello build. Unfortunately, it says hello conference. So I made a bug somewhere in my application. It's not doing what I expect. So I need to go in and figure out where that particular piece of logic is. Unfortunately, I've, in the course of coding quickly, built up a couple other classes in my project. So instead of scrolling around and trying to find the right place to set the breakpoint in my project constructor, I'm going to start debugging by stepping into my project. So step into or step over will have the same effect here, F10 or F11 for people that are used to using the keyboard shortcuts. So I'm going to choose step into. Visual Studio is going to start debugging, and immediately I'm into the constructor of my application. So the debugger automatically steps you into the entry point of your application. So that's your next tip, that you can start debugging with stepping, which can be really, really nice if you don't want to hunt and find the breakpoint for the particular entry point to your application. So I'm going to go down here, and it looks like on this particular line that I'm building my greeting string, and it's doing a string concatenation. It's doing a get greeting, get conference, and get punctuation method call. Now, because of these are method calls, I can't just hover over them and get a nice data tip telling me what the value is. I could debug into each and every one of them, or I could go manually type them into the watch window. But as of Visual Studio 2013, again, we're in Visual Studio 2015, when I step over that line of code, the autos window, and now in Visual Studio 2015, the locals window as well, shows me what are called return values. And so I can see all of the methods that I just stepped over, the values that those return. So that's a really useful way to debug code. Thank you. So that can be a really useful feature when you're just trying to understand. Obviously, the applause indicates you see the value. So the other thing to note is if you're a watch window aficionado, they're not going to show up there, but if you prefer to work in the watch window, we have something in the debugger called pseudo variables. They start with $. These are all documented, but you can choose return value, and it'll show you the return value, and then it's a return value n. So if I want the next return value, I can do return value 1, and then 2, 3, 4, 5, up through as many return values as there were. If there weren't one, they'll stop evaluating. So you can always just keep a return value pseudo variable if you prefer to spend your time in the watch window, and that'll automatically evaluate for you as well. So based on my return values here, I was able to see that the problem is that the get conference functionality returned the wrong thing. So I want to debug down into that now. Does anybody know set next statement? Set next statement's a really useful piece of functionality in the debugger that lets me move my execution context around so I don't have to restart my application, right? I've already passed this point. So instead of having to stop debugging and restart, I can simply right-click and choose set next statement, which is down here. Control-Shift-F10 is the keyboard shortcut. Or I can just drag it in the gutter over here, and now execution will do that. The only thing to note is that this does not change the state of your application. It's not an undo. It truly simply moves the execution stream. So you'll notice that greeting here, if I hover over it, has a value. It's not null because it was assigned the last time I executed this line. I'm simply going to re-execute the line. So if you have certain things that can only execute one time or they have side effects, set next statement will not avoid any of those side effects. So now I'm here. I want to debug into the get conference function. I could go navigate down to the definition, set a breakpoint, F5, and get down to it that way, or I could step into the get greeting function first, then come out, then step back into the get conference. But I have another handy feature I can use in the debugger. I'm right-clicking. I'm going to go to this thing that says step into specific, and this is going to give me a list of all the method calls on that line. So this only works for .NET Talk. But we have the list of all the method calls, so I can choose the get conference. And what that's going to do is set a one-time breakpoint on the entry point to that method, and it's going to run execution to that point and stop for me. So when I click get conference, it executes to that point, and I'm now into a specific method. So this is, you can see the utility of that when you're dealing with a line that has a lot of method calls on it. And so now I want to get down in here. I can see that I'm doing a comparison looking for where the parameter equals conference. And so instead of setting a breakpoint, running down there and deleting it, I'm going to use another feature to control my execution that's called run to cursor. And this is a really useful feature. I use this all the time. It's one of my favorite features in the debugger. Once you learn how to use it, and Control F10 is the keyboard shortcut. So a lot of times I just click and Control F10 rather than right click. But when I do run to cursor, it runs execution to that point. So it's a one-time breakpoint, right? Didn't have to set a breakpoint and then delete the breakpoint. And it looks like what I've done here is the parameter is conference, and then there's a space, and I need to get the conference name. And I really want args of x plus 1. So I want to go ahead and fix this, and I want to fix this in a nice, robust way. And I'm going to use a feature that we call edit and continue in the debugger, which is the ability to edit code while I'm stopped in the debugger, hit F5, have it continue running, and my changes are going to be applied. So let's go ahead and fix this. I'm going to go x plus 1, and now I'm going to hit continue debugging. Let's step over it. All right, conference here is build. It's exactly what I wanted it to be, so I fixed my bug. And now what I want to do is I want to get back out of this particular function. And I can do that by using the step out feature. Does anybody here use step out in debugging? Okay, about half the room raised their hand. If you're not aware that the debugger has a step out feature, that's going to bring me back up to exactly the last instruction that method finished executing. So now, if I choose step in again, I'm not going to go past that line of code because I literally came back out to the point that I entered. If I choose step in here, I'm going to actually go into the get punctuation function. And now when I F11, I'm going to be down further down. Now everybody here uses the step out feature. Did you know that you can use the run to cursor on the call stack in deep call stacks to achieve the same functionality? So notice I'm 3 methods down here. I'm going to right click on my main window. I'm going to choose run to cursor, and it's going to run back up the call stack to the point that it entered that. So notice I was down 2 methods. Step out would have brought me up 1, but run to cursor in the context of the call stack window will actually bring me all the way back up to wherever I chose to right click. So that can be a good way, if you're in a deep call stack, to unwind that quickly. right. So briefly, here's a quick reminder of the things that we talked about. Does that work for people? That's kind of the thing that we're going to do for about the next 40 minutes. So hopefully that's useful to you. All right, so let's go back to the product. All right, so now that we have this particular application up and running, let's go ahead and restart it to make sure we're in a nice fresh start. What this WPF application is ultimately going to do, it's ultimately going to connect to a web server and it's going to retrieve some information. This is an application that I've been developing with colleagues. We're trying to get an inventory of all the sample code that we have from when we do events like this. The first thing I want to do is I just want to test the loading of my data. So I have a button here that's going to say load data. And it's going to go down and it's going to break. And it's going to break on a line. If you look at the code, it's a debugger.break. Did you know that you can embed breakpoints in your code using debugger.break? You don't have to just set them from the IDE. So you can actually hard code breakpoints in there. Now, the interesting thing about hard coding a breakpoint in there, does anybody know what happens if I have a debugger.break in there and I run it without a debugger? It crashes the application. So a breakpoint is actually a special type of exception that's understood to be a breakpoint. And so without a debugger attached, you throw an exception, it's unhandled, the application crashes. So I've also wrapped it inside of this property called debugger.isAttached. So this is something that you can do in your application where you can actually code for debugging, where you can say, hey, if I'm debugging, I want this to happen. So in this case, if I'm debugging, I want to break. But if I don't have a debugger attached, don't execute this debugger.break or don't behave in some other method. And actually, a lot of the Windows Store app templates have this logic in there in certain places where they'll turn on extra diagnostics tracing. If they'll have if is debugger.attached, turn on some additional tracing, or if debugger.isAttached, debugger.break in certain failure paths where an exception might get thrown, handled, and then rethrown somewhere else. Inside a catch block, they'll actually do this to you so your application doesn't just disappear. You know what's going on. So that's another 2 tips for you. So I have my data provider up here. My data provider looks like it's been correctly initialized. Well, hopefully. Let's dig in and look at it. It didn't error out. And I can see that there's quite a bit of data in here. And so I have some properties. Let's start by looking at the JSON property. And it looks like there's stuff in there. Let's say I want to get a better view of it than I can see here in the data tip or down in the watch window. You'll see this little magnifying glass over here to the right. And the magnifying glass indicates that we have a visualizer. So once I click the magnifying glass, it's going to open a different view on top of that data. And there's a little down arrow. And so we have 4 built-in text visualizers into the product as a Visual Studio 2013 Update 2. We have a normal text visualizer that just will visualize any string. You can choose wrapping or not wrapping. It's up to you. Although in this case, it's JSON data. So the text visualizer isn't going to do me a lot of good. So I'm going to go ahead and select the JSON visualizer. And this is going to pop up, and it's going to let me explore my JSON in a nicely formatted manner. It supports search, so I can see I have an app type of web. So if I want to search for all the places that I have web, you can see that that happens, and that's going to happen very quickly. And the next time I come back here, it's going to remember, oops, sorry, hovering on the wrong thing. It's going to actually remember that I had selected the JSON visualizer. So you don't have to select a different visualizer every time. Once you select it, we're going to remember what you selected for that variable for the lifetime of that Visual Studio instance. So that was the JSON visualizer. So now let's go down here. We have XML data. So we have an XML visualizer. Gives you nicely formatting on the XML. We have an HTML visualizer as well. So it's going to format HTML for me, which makes that a lot more readable. And then up here, it says application data set. So this is a data set. I can see system.data.dataset. There's only one visualizer available for this. It's a dataset visualizer. When I open that, that's available to me as well. And so that lets me explore all the data in my data set. Very useful when dealing with databases. And then the last visualizer that's baked into the product that I wanted to talk about is the WPF visualizer. So if I go down to my autos window, I can see that this is here. This is my WPF main window. And so we have a WPF tree visualizer built into Visual Studio for that. When I open it up, I can explore the visual tree. Down in the bottom left, I can see a rendering of whatever element I have selected. And then over on the right, I can explore the properties for any of those given elements. So those are the 6 visualizers that we bake in by default that are owned by the core debugger team in Visual Studio. You can write your own. It's really not that hard. MSDN has documentation on how to do it. So if you're interested, you deal with a certain complex data structure frequently, it'll take you an hour to write a visualizer for it. Maybe well worth your time in terms of debugging. Think about trying to debug a data set using just drilling through data tips versus having a nice visualizer for it. So, all right, so now I want to explore. So it looks like my data has gotten initialized somewhat correctly. But I want to look at these apps, the lists that are coming back, because that's really the important information. That's what I'm going to be dealing with. And my first thing as I start dealing with this array is I have this thought, I really wish that I had a more useful view in this particular, the debugger's view of this. So I'm going to go in and I'm going to tell the app how to present itself to the debugger, the class definition. And instead of navigating, I'm going to right click and I'm going to choose peak definition. Most people are probably familiar with F12, go to definition. We also have functionality in Visual Studio called peak definition that's going to just open this little window in the middle of my editor, and it's going to allow me to edit that file without having to have the big context switch to jump. So in this particular case, I want to add a debugger display, and I don't have the right thing, so tip, most people hopefully know this, but if not, control dot is going to give me the IntelliSense for that. So when I hit enter, it's going to go ahead and add the correct using for me. And then now when I come in, I'm going to specify the debugger display attribute. It takes a string as a parameter. I can type plain old text. So I'll type app, and then I'll just displays app to me. And anything I put inside curly braces is going to evaluate the property on top from the particular application. So I'm going to say app type in this case, or let's say app name. And see how I have this IntelliSense dialog covering stuff up? A very helpful tip. If I hit control, that becomes transparent. So anytime you have a pop-up in the IDE, if you don't want it to go away, but you also want to remember what's under it, control, transparent, let off control, and it comes back up. All right, so now I've added an app name. You'll see these little red squiggles. That's telling me that I can't actually apply this via edit and continue. A display attribute has to be rebuilt, so that's OK. I'm going to click the restart debugging button. You don't have to manually stop and then go click restart. We actually have a nice restart debugging button for you. I'm going to come back. I'm going to hover over apps, and now when I expand it, by adding the debug display attribute, it's telling the debugger how it should present that data to me. So it's saying app 0, app 1, app 2, app 3, app 4, et cetera, et cetera. So I can put anything I want in the debugger display attribute. There's also other debugger star attributes that you can go look up on MSDN. I'm not going to cover them, but you can actually even go write additional classes that choose how to format the class that you're looking at. So that exists for some of the framework types. So now that we're inside our data tip, I've mentioned this already with the IntelliSense, but it works for data tips as well. I've made an investment in drilling down, and I press control, and it goes transparent. I'm not going to lie, it's kind of fun. It doesn't really make me more productive, but if you're ever sitting at your computer and kind of tired and you just want to play, it'll make you happy. And notice that I have this little pin icon over here. Has anybody ever pinned a data tip in Visual Studio? Okay, about less than half the room. So when you click the pin icon, it's going to stick it in the editor for me. So now it's here. I can do whatever I want with it. So I'm going to go ahead down here. I'm going to set a breakpoint, and I'm going to run to this particular breakpoint, and I'm going to look at the app. This is particularly useful, the ability to pin these things when you're dealing in iterative situations. I find myself using them in loops a lot. So now here, as I hit F5 and run between the breakpoint, I can just watch the value update. I can manually add expressions to it if I wanted additional stuff. So I could say add expression, and I could do app dot, let's say, display languages, and that'll evaluate for me. So I can build up my own little watch inside the editor if I want. I can even make comments if I'm trying to debug a really hard problem and I'm trying to remember what the previous values were. I can say, so in this case, app, it's so type equals C#, if that's helpful to me. And now I hit go out here, and I'm going to run to the next breakpoint. And now it's going to be type equals VB. So you can take little notes like that. You can collapse them. You can expand them. They come back. You can even float these if you have put them somewhere that they're really out of the way, like up here. So the question is, do they get saved with the project? They do get saved with the solution. They get saved the same place that breakpoints get saved. So now if I come back, I'm going to show one more thing. I can back over the editor, so I can pin this again. When I stop debugging, you're going to see that it still remembers that they're there, And when I hover over it, it's going to show me the value from the last debug session. So this can be kind of handy. You stop debugging, hover over the little pin icon, it's going to show you your previous values. So let's go ahead and come back. All right, so we're in here. We'll run to our breakpoint now. We talked about these. We'll go ahead and get rid of that now. I don't need that. So now I'm down here in my watch window. So let me say I want to build up some state in my watch window. And let's go ahead and drill in on my app. Do you know that you can add things to the watch window from here? So I might want to say app ID, and I can say add watch. And then down here, I might have app. And I can even do that from in the watch window itself if I have state that I'm particularly interested in. So owner, maybe I just want to make this a top-level attribute. So I'm going to say add watch. I scroll up, collapse this, and now it's nicely there. So what happens if I need to watch this? So I'm operating on this app, but I'm going to step into the get languages for display. What's going to happen to everything in my watch window? I'm going to lose the ability to see what its properties were when those particular variables are not in scope, even though they're still in memory and theoretically inspectable. So I'm going to step back out of this, and I'm going to use a feature that is going to allow me to track the object even when the variable name is not in scope, so I would get a compiler error. So let's track the app ID. And I'm going to right-click on it, and I'm going to choose a functionality that is called, if I can find it, make object ID. There we go. So this particular one, it's not available on this primitive, but so you have to have a real object. So I'm going to choose make object ID. And notice it adds this little $ now to the right of it. For those of you who have used this feature prior to 2015, you'll notice the syntax has changed a little bit. We used to use a hashtag. There was a couple reasons we made that change. First of all, we had an inconsistent syntax between Visual Basic and C#. Now both of them use the $ number for the object ID. If I go create more object IDs, it'll have 1, 2, 3, 4, 5, 6. And the other reason is we talked about pseudo variables already. It was consistent with the debugger concept of pseudo variables. So now I'm going to go down here and I'm going to type $1. And when I step into this get languages for display, helps if I step in and not step over. You're going to see that all of these other variables are out of scope, but I can still actually see the value of the $1. So make object ID is a feature that allows you to track your objects. If you want to see their values, they're in memory, you know they're valid, but you might be stopped in the debugger in a place where you can't actually access them by variable name. So that's a tip for that. And then I can right-click, and I can say delete object ID if I'm done with it. So, and then I have to delete the watch. All right, so let's come back over to PowerPoint very briefly. So there's a very brief review of the tips and tricks that we talked about in this particular context. Are there any questions so far? Okay.
So why don't you have debugger.break only break when it's attached? Why crash the application?
So the question was, why don't you have debugger.break only attached when, or have the logic to only break when the debugger is attached? It was actually added by the .NET framework, so I don't 100% know. I can only speculate. But I'd speculate, I've talked to people that actually have found it to be a useful thing sometimes to actually crash their application. You have a code, almost use it like a throw not implemented exception. But it's a great question. I don't actually know. It comes from the system, from the runtime itself. It's not added by our team.
So the little pinnable watches, like if I put that in a solution, is that going to like the user specified stuff, or can I share that with like the other developers in the project?
Great question to lead me back to Visual Studio for demo number 3. The question was, if I use the pinnable data tips, can I share those, or does it just go into my solution? And the answer is by default, it just goes into your solution, but on the debug menu, you can actually choose to, if it scrolls down, export your pin data tips and share those with a colleague. So by default, they're just saved with your project, but you can take an explicit action. So if you built up some interesting debug state and you wanted to export those data tips, you can do that with your comments and all. They can import them, and it will go to the same source line files that you were on. You can also export breakpoints. That's another thing I wasn't going to show, but since we're on the subject of exporting, so you can theoretically export a breakpoint along with the data tip, say, hey, import this, press F5, you'll hit this, and you'll see the data tips that I built up with their state. No action required. All right, so let's go ahead and move on past, get rid of my breakpoint here, and we'll go ahead and restart debugging just to come in a nice clean state. So now that we validated that the data is getting loaded correctly, I've written some tests to make sure that what I'm going to do is I have a secure communication boundary between the client and the server. And so my tests are going to encode my parameters that I'm passing up. They're going to be decoded on the other side. I'm not actually going to make the web call in this particular case, but I'm just going to test the libraries themselves. And I'm going to make sure that everything works correctly. And so when I click my Run Test button, I can see that 2 of them succeeded and 1 of them failed. So I'm going to jump in and debug this. And so if I go down here, I have my Run Test method. And so I'm going to go ahead and jump into this Get Apps by Type, and this, which is where the decoding is occurring. And I know that it's only failing for desktop, remember. So I could have a couple options that I can do here. Option A would be I could set a breakpoint, I could hit it, I could set a watch, and I could just wait till the value got to be what I wanted. Or I can set a breakpoint that'll ask the debugger to only stop when the value equals what I want it to equal. So notice I have a disabled breakpoint here. That can be a nice sort of way to bookmark things if you're not interested in them. But notice when I set a breakpoint now in Visual Studio 2015, you see this little toolbar pop up here. This little toolbar lets you disable or enable the breakpoint. And it also lets you open the breakpoint settings, which appear as a non-modal peak. We have a couple settings you can apply. You can apply conditions. So we have a conditional expression. This is conceptually anything that you could type in an if statement. So in this particular case, I actually need to move my breakpoint down 1 line. I set it on the wrong line. So I can adjust that here. I can just do line 23 instead of having to delete it. And it's going to jump. There is a quirk that doesn't rearrange itself, but that's how you can move a breakpoint. And so now I'm going to say conditional expression. I want to say decoded type. Notice I'm getting IntelliSense in here, just like you would expect. And let's say desktop. So now, when I run this again, notice that the web and mobile execute first, and then desktop executes. So I'm going to click my Run Test button. And when I stop, I'm going to see that my decoded type equals desktop. So the conditional breakpoint has stopped me only when I asked it to, so that condition's been satisfied. If you're wondering, the other conditions available to you are we have the concept of hit count. So this is purely based on the number of times that the breakpoint's been hit. You can choose to do it based on an equals, is a multiple of, or greater than equal to. So sometimes I find it useful in certain situations to go, oh yeah, I know I want to stop the first time I get here. I'm going to set it to be a hit count of 1. Then I don't have to remember to delete my breakpoint, because I'm guessing, like many of you, I a lot of times forget to set breakpoints. When I'm debugging something, I go, okay, I think I got it working, F5, let's go test it again. And I'm stopping at all these breakpoints I forgot that I had set. So hit count can be a useful way to make sure that you stop once, but you don't have to remember to sort of delete and recreate the breakpoint often. And then we have something called a filter breakpoint, which is in my slides on multi-threading tips. It's basically about debugging code that's running in parallel. So you can see the conditions are based on machine, process, or thread information. And I can combine these. So I could do a conditional expression in conjunction with a hit count, and that would work. And then we'll talk about the actions here in a little bit. So now that we're in this place and we're stopped at desktop, and I can see that the decoded type equals desktop, I want to double check, because I'm pretty sure that there's applications of type desktop in here. So one way would be to go drill through this applications list and look, but wouldn't it be a lot nicer if I could just query this? So what I'm going to do, and what I actually wanted to do here was not that, but that's okay. So I'm going to go ahead to the immediate window. This would work in the watch or the locals or any of the other windows, but I'm going to type a query. So let's say data.applications.select a.app type, and let's do .distinct. And it works. So as of Visual Studio 2015, you can now evaluate Lambda expressions in all of the debugger watch windows. So even better, or perhaps just as good, I think I see my bug, and that is desktop has a capital D here, desktop has a lowercase d in this particular case, and my equals has not asked it to be case invariant. Now, wouldn't it be awfully great if I could apply, edit, and continue to my Lambda expression? As a Visual Studio 2015 RC, you can. String comparison, dot ordinal ignore case. Let's hit F5. And it passed. We fixed our bug. Edit and continue for Lambda expressions. Lambda expressions in the watch window. I'm done, thank you. All right, so now that we've got that working, I want to make sure that things actually work when I try to query the server. So I'm going to click this Get Apps, and this is now going to actually make my first call out to the server that we've looked at today. And it goes, and it's going to tell me an error occurred contacting the server. That makes sense. The server is another project that's in my Visual Studio solution, and I forgot to start it. So instead of having to go back and do a lot of rigmarole, do you know that while I'm debugging one project, I can right-click on the project, say debug, start new instance. It's now going to start. I know what the problem is. This is the DLL that I just edit and continued in is shared between the two projects, and so it wasn't happy that it couldn't rebuild it for the web server. So, sorry, that's what I was doing. All right, so get apps, it's going to fail. Solution Explorer, now I'm going to right-click. Now I'm going to say debug, start new instance. That will work correctly. And so now when I come back here and click Get Apps, I can click Start. It'll take a couple seconds because the web server has to now spin up, and everything worked correctly. So debug, start new instance. That's a little tip if you're working with multiple projects. But that's going to be kind of a pain to remember and do frequently. So what I'd prefer to happen is I'd prefer to have my web server launch every time that I start debugging. So I'm going to go to my project properties, and I'm going to go to the solution properties now, not the individual projects. And I'm going to go to this startup project tab, and I can configure multiple projects to start up. I can choose to start them with the debugger, or I can choose to start them without the debugger. So if I wasn't particularly interested in the web server, but I just needed to make sure that it started, I could say start without debugging. Every time I press F5, it's going to start debugging the WPF application. It's not going to start debugging the web application, but it's actually going to launch. That's OK. I'm OK debugging it in this particular case. Let me go unset this breakpoint now. And excellent. So everything's working great up to this point. The next piece of functionality that I would like is if you see this app type dropdown, I want to make sure that I can filter by the various app types. So if I select mobile, I expect it to only show me the mobile. And I'm doing all of this logic server side. Let's go ahead and see what happens when I try desktop. And I'm getting nothing. We just proved with our Lambda expressions that there are actually applications of type desktop. So what's going on? Let's go ahead and jump over to our server-side code and debug it. So actually, I'm going to go ahead into this app data provider, directly where I'm decoding it again and make sure everything is correct. Remember, this library is shared between the two of them. So when I come down here, I'm going to set a breakpoint. And I'm going to go ahead up here. This I'm going to have to, and then I'm going to go try to hit the desktop again. And when I break, I see that the decoded desktop, after I've unencrypted it, is actually coming through. I'm losing the P for some reason. So that's why I'm not finding anything. How do I figure this out? I have a library that's doing all of my encoding for me. It's encrypting and decrypting the string. And I'm just going to tell you that the problem is actually down in that particular layer. So we're going to go find the functions down here that actually are going to do the byte shifting on my characters as I'm encoding them. And what I want to do is, because it's a long string, I don't want to debug and stop and hit a breakpoint inspect every time. I want to just be able to dump all this information. So I'm going to go down here and I'm going to choose actions. And I am going to set what in Visual Studio is referred to as a trace point, where I'm going to print a message to the output window, and then it's going to automatically resume execution. So when it encodes and decodes those strings in desktop, I'm not going to stop at all. I'm just going to have a record of everything that happened in the output window. And there's three types of text that I can type. I can type plain old text. So here I'm going to say encoding. And then anything I put in curly braces, much like the debugger display attribute, it's going to be evaluated. So I want to say byte to mask. I get IntelliSense as you would expect. And that's going to go to the value of masked. And then we have pseudo variables again here, $, and I can choose to output relevant information about the project. You can see what they are. Call stack is an interesting one. Sometimes if you don't know how you're getting to various places, you set a trace point, you can ask it to dump the call stack. In this particular case, I'm just going to dump the function, because we can, and I'm going to go ahead and close. And then I'm going to set an equivalent trace point down here where I'm unencrypting the string, and I'm going to say decoding, and we're going to do the same thing. We're going to say byte to unmask went to unmasked, not unchecked, unmasked. And that should work for me. So I can either leave this open. This is a nice non-modal peek window. If you've ever used this functionality in previous versions of Visual Studio, you'll remember all of the functionality for conditions and actions lived in all completely separate dialogues. It was theoretically combinable, but you had to right-click, open a modal dialog. You couldn't copy and paste from your editor. I can still interact with my editor if I want. I can close it if I want. But now when I go ahead and start debugging, and I'm going to click the Get Apps, I'm going to choose desktop, and you're going to see the particular string that I had output here. I left my breakpoint set from before, but that's okay. I have a record of everything that was encoded and decoded. So trace points I find really useful when you're doing iterative things like this, and you need to understand it's actually really hard at any given point in time to stop and get the full picture. And so remember, I'm dropping the P, so I can see that it's being encoded. The last character is being encoded to 112. It's being decoded, or sorry, it's being encoded from 112 to 38, and it's actually being decoded from 37 to 111. So somehow, when it's being passed across that web boundary, it's actually modifying the character. And if I go look at my ASCII table, it turns out that character 38 is an ampersand, which is a special character, so it hasn't been escaped. So the browser, actually in the process of making the web request, is changing that. So I need to fix this particular issue, and I want to fix that down here before I actually, without stopping. I'm not going to use edit and continue in this particular case. I am going to rather use the ability to simply modify variables. So let's go ahead and come back out here. Go all desktop, and this particular functionality supports base 64, which will not have any special characters. So I can simply modify the value of this in the debugger, hit F5, continue debugging, and everything works correctly. So it's another feature in the debugger, is that you have the ability to edit values directly in memory, which can be a great thing to test out hypotheses as opposed to stop, change the value, right? Maybe you want to see what happens to this conditional branch if I null this out or make it some wonky value. And you can do that directly in the debugger. You don't need to stop and modify code every time. So, any further questions?
When you were doing that run multiple instance thing, and so you get two things running in the debugger, can you actually, like when you're building the breakpoint or using the output window or the watch window, how do you know which one of those two sessions you're actually scoping to?
So the question, if I understand the question you're asking, I was debugging client and server. How do I know which one I'm scoping to when I set the breakpoint?
Or yeah, or a watch or a mediate or whatever.
So the breakpoint will be hit unless you apply a filter. Any process that hits it or any thread that hits it in multi-threaded debugging is going to always stop on the breakpoint. The watch is going to always evaluate in the context of the thread that is currently selected under the debugger. So by default, it's the one that you hit the breakpoint on or stepped on. And so you are able to, so let's go back to the product really quick. So let's go ahead and just click another button. So by default, right, I'm on this particular thread. So here's another tip. I have the debug location toolbar visible. This comes by default in the general profile. I don't think it comes by default in any of the other ones, but I can actually see all the threads that I'm on. So if I switch to a different thread, so I'm on main thread, if I go to this system events thread, you're going to actually see in the localism watch window that I can't evaluate any of these things because I now have told the debugger that the context is a different thread. Does that answer your question?
Yeah.
All right, so we'll go ahead and just move on while we are here. And on to our last demo of the day. So our last set of demos. So I've got pretty far along in this app that we're building together. It now loads correctly. My tests all pass. It seems that it works correctly across the web boundary via my encryption and decryption, so it's nice and secure. But what happens if, for some reason, something goes wrong? And you saw this before when the server wasn't running. Error occurred contacting server. What I want is I want the debugger to stop and tell me what the problem is. When I first had my first job doing my VB.NET development, I didn't know how to make the debugger stop for me when exceptions occurred. So I'd actually go into my application, and I'd find my try catches, and I'd comment them out. So I'm guessing everybody here has done that at some point. Fortunately, in the debugger, we have the ability to configure the debugger to stop on exceptions. And if you have not seen this yet, how many people here before have used the old exception settings in Visual Studio? How many people here went and got coffee while the window came up? Well, fortunately, in Visual Studio 2015, we redid the window, it's lightning fast, and it actually has a respectable search. So for those of you who are not familiar with this functionality, what this gives me the ability to do is I can right-click, and I can, or not right-click, I can check particular exceptions or groups of exceptions, and I can ask the debugger to break whenever the exception is thrown, as opposed to the default behavior of the debugger of only breaking when an exception is unhandled. So in this particular case, now, we're running. I've now asked the debugger to break when any common language runtime exceptions. This is .NET. For those who may not know, we call the .NET runtime the common language runtime, or the CLR. You'll hear it referred to as both. And so when I open my main window and I collect my error this time, it's going to stop me down here where the error actually occurred. So awesome. That's useful functionality to be able to stop without having to go in, find my try and catches, comment them out, and get the debugger to actually stop me. And this is, in async programming, it's even more important because how many people here are doing async programming with await and tasks? Okay. How many people here may have ever gotten burned by this particular particular problem, that even if I don't try catch it, anybody tell me now where my app is going to stop when I hit the exception? All right, well, let's look and see what happens. Oh, first chance exceptions are still on. It helps if I remember to turn this off. So now, the unhandled exception will actually bring me back up to where I'm awaiting on the asynchronous call. I will apologize in advance for this. It's something I would like to fix for you in the future. Given the way the .NET runtime works, it's an incredibly hard problem to solve. So for now, the appropriate way to diagnose where exceptions are occurring inside of asynchronous message, you'll need to come into the exception settings and enable first chance exceptions. So let's go ahead and restart and do this one more time. So let's go ahead and say error, because there's one more thing I wanted to show you. A lot of people raise their hand that they're doing asynchronous code. How many people here are on a version of Visual Studio older than 2013? Okay, very few people, but a couple people. So many people here have seen what we introduced in 2013, and it's called the async call stacks. So I'm going to show another quick tip. You know when the Visual Studio actually has a third IDE mode, and it's called the full screen mode of the IDE. And it remembers your window layouts just like it does between debug and design time. So now when I go to debug windows, FYI, all the debugger windows are under debug windows. We see a lot of people in UX studies that go looking for them on the view menu and other windows. A reasonable place to look, but it's not very useful because they're not there. But now I can open the call stack window, and I have it docked over here. I did this before the session. And notice that I have these pseudo frames. We call anything that's in square brackets and grayed out a pseudo frame in the call stack window that says async call. And this lets me know that an asynchronous call occurred, so I'm awaiting on something, and it's actually running on a different task. So prior to Visual Studio 2013, before introducing this feature, the only call stack that I would have seen in this particular case would have been that. So what we've done is by introducing the async call stack functionality, we let you understand when you stop somewhere unexpected or you're debugging asynchronous code, how did I get here via my code flow, not just what's the current call stack of the current thread that's executing. So we think that's a really useful piece of functionality as well. And the last thing I'll note while we're in the call stack window, or two more things, is we have this concept of external code. External code means that Visual Studio is hiding a bunch of goop from the runtime for you, a feature that we call just my code. Just my code in .NET controls both stepping. So if I try to step into this HTTP web response, which is part of the framework, it's going to be treated like a step over. And then the call stack looks much more pleasant. If I want to turn that off, I can choose right-click and I can say show external code. And now you understand why we have just my code. So that's what it does for you, and that's what that little gray bracketed square bracket thing, external code, does. That means the debugger is hiding framework code from you that we don't think is particularly useful to you. The last thing to note is you can configure other options on your call stack view. You can choose to show parameter values. It's off by default. So normally it would look like this. When I choose to turn it on, it's going to show me the parameter values. If I don't think that the parameter names are particularly useful, because I have my code, so I can customize it like this, so I can just have the values. The only thing to note is when you turn values on, the reason it's off by default, you will incur some performance penalty evaluating the call stack, just like evaluating things in the watch window. The debugger has to do work to get the value of that. So if you have a lot of parameters or parameters that are expensive to evaluate, that will slow down every time you stop debugging. So either hit a breakpoint or step if you have the call stack window visible. Obviously, we don't evaluate them if we don't need to. So let me go ahead and turn off parameter values, turn on parameter names. That's the default state. And we're good to go. Now when I exit full screen mode, my IDE goes back to the same view that I had before. So that's another great tip, is the view full screen mode in the debugger. So last thing I wanted to talk about, because a lot of people raise their hand, they deal with asynchronous code. How many people here have ever used the tasks window? Okay, a few people. So the tasks window will show you all of your running tasks, and implicitly, any of your asynchronous functions are actually tasks. So if you have something hung, or you're trying to understand the relationship of what the state of your tasks are, you can open debug Windows tasks, just like the rest of our windows, and we'll show you all the tasks. So in this particular case, I'm in the task that's doing the web request, and then I have my two other asynchronous methods are actually awaiting, and it'll tell me which task it's awaiting on. So in this particular case, the get apps from web async is awaiting on task ID 273, which happens to be the active one, and task 276 is awaiting on task 275, which is the asynchronous method that it called. So that's a gem if you haven't used it, but you're dealing with tasks and asynchronous code a lot. That's functionality that's also available to you in the debugger. It's another window that our telemetry shows us not many people find, so I wanted to make sure to call that out. All right, so brief review of the things we talked about. That's going to conclude the demo portion of our talk today. We only have about 5 minutes left. So are there any questions before we move on? Question right here. Mm-hmm. The question was, does make object ID prevent the garbage collector from collecting the variable? My recollection is yes, it will prevent the garbage collector from collecting that, because we have to actually add an additional reference to it so we can track it. Question over.
So I've had many times when edit and continue is blocked for me, and try to edit and continue and the ID complains. Is there a general rule, or is there just a bunch of exceptions?
So the question was, edit and continue fails for me a whole lot. Is there a general rule, or are there just a bunch of exceptions? The answer was, there were a bunch of exceptions. As of Visual Studio 2015 RC, we have removed the vast majority of those exceptions. You'll see the blog post today that talks about the Lambda support. There was a blog post when we released CTP6 that talked about the ability to do it in async and all of the new C#6 language features. So it's now more of a small list of exceptions, and if you hit blocking issues, definitely let us know. There's still a few limitations, like you can't edit inside of catch block still is one limitation, for example. So I promised you a few slides of multi-threading tips, parallel stacks window, URL, go check it out. Threads window. This offers a lot of interesting functionality for dealing with threads, including the ability to freeze and thaw threads that will let you force your threads into particular states. So get to a certain point, freeze it, it's not going to run past that, run a different thread to a different point, freeze it, so you can try to simulate what particular race conditions would be in that particular way. Additional multi-threaded tips, show threads in source, run selected threads to cursor, debug location toolbar, and I mentioned the filter breakpoint, and we briefly discussed the debug location toolbar. I apologize, I realized I forgot one thing off here, so I'll verbally insert it. We also have a feature in the IDE called the parallel watch window. The parallel watch window allows you to see all of your threads that are executing in parallel. Since we have about 4 minutes, do people want to see it really quick? Awesome. So let's go back to Visual Studio. Let's close some windows. Let's go get the button that will show it to us visible. Come down here. You should be visible. And now when I go, it helps, I guess, if I type valid XAML. All right. Solution Explorer. Let's go down here to number utilities. So what I'm going to do in this particular case is I'm going to try to calculate some prime numbers. And I'm going to do that in parallel, because as you know, calculating prime numbers can be extremely expensive, which is why encryption actually works. So I'm going to set a breakpoint, and I'm going to go ahead and set it as a hit count, so the threads can kind of ramp up and get there. All the threads can be spun up. Let's make it equal to 700. So let's go, boom, back here. I'll click my button parallel. Another tip really quick, I mentioned the conditional expression. Hit count is faster than conditional expression because the debugger has to do less work. So if you're in a situation where you happen to know the count, like it's an iteration with an x variable, 4 into I equals blah, if you can use the hit count, it'll be a little faster than that conditional expression that I showed you. But so I'm going to go ahead to the debug. I'm going to go open the windows, and I'm going to open the parallel stacks first. I mentioned this. It's going to open up here. So this is going to show me all of the particular threads. And then the other window that I wanted to show you is let's go ahead and run the cursor down in here so I can get inside here, the feature called the parallel watch window. And what this does, this is going to show me all of the values of a particular variable across all of the various threads. So I can see the number of threads that I have running, and I can see the value of I on all the various threads. And one more cool little tip while we actually happen to be here is the immediate window. Do you know you can call random code from the immediate window? So string utilities, and I'm going to call a reverse string method that's going to execute recursively, and let's say it hello. It's going to hit a breakpoint, so while stopped at another breakpoint, I can debug into other methods. We call this reentrant debugging, and now in this particular case, in the case of recursion, let's run down here. I happen to be in the first breakpoint, which was a hit count breakpoint, as I mentioned before. Let's run the cursor at the end of my recursion. If you see my call stack, I'm this many threads deep, and when I open the parallel watch window, I obviously is not a valid expression in this particular case, but str is. I can see the value of the parameter all the way up the recursion stack. So that is the last 2 bonus tips for you for the conference. So I'll come talk to me afterwards. I want to get through. We only have about a minute left, but I'm happy to answer questions afterwards. And then I'll also be at the Visual Studio booth up on the 3rd floor immediately after this once I clear out. Here's a link to our blog. Here's a couple other related talks. I mentioned I'll be giving a performance tools talk, half of one tomorrow evening. And then my colleague Angelos will be talking about the historical debugging capabilities. And lastly, evaluate the session. If you found it useful, please go give me a good rating so they let me come back to future conferences.